Monk's Mound, Cahokia, Illinois. State Site Number 11, MS-38. It is the largest earthen monument north of Mexico. It is also, on the documentary record, one of the least completely published. This is a source-critical narrative. It works from a defined corpus, a Freedom of Information release covering Capital Development Board Project 104-021-016, the 1984 McGimsey and Wyatt Limited Investigations, the 2005 Hadjic Preliminary Stratigraphic Evaluation, and a set of evidence plates compiled by Barrow's research. Every claim carries a grade: proven, sure, supported, unresolved, contradicted. Where the record stops, this narration stops with it. Part 1. The monument on the record. Before any argument about damage, authority, or interpretation, there is a physical object and a set of drawings that describe it. We begin there. Monk's Mound is Cahokia's largest earthwork and its central vertical feature. The record supports a long construction sequence rather than a single dump of soil. Internal stratigraphy includes prepared surfaces, repairs, and added episodes. That distinction matters more than it may sound. A monument built in stages is a stratified archive. A monument built at once is only a pile. Because the interior is layered, even a small cut can cross a unique surface that exists nowhere else in the mound. Note also what this plate does not do. Great Serpent Mound and the Newark earthworks appear here as background references only. This corpus does not independently document a general Adena to Hopewell typology, and it is not offered as evidence for one. This is the topographic survey of Monk's Mound prepared by William H. Graff in June of 1964, drawn for the Forest Preserve District of Cook County, Illinois, at a contour interval of 2 feet. Reference to mean sea level. It is a preliminary sheet, and it's labeled as 1. Its value to this investigation is not aesthetic. It is a dated baseline. Any argument that the mound's surface has changed by slumping, by erosion, by repair, or by excavation has to be measured against a surface that was recorded before the change. The legend records stumps, reference points, a borrow pit, and a drainage ditch. Those last two are not incidental. Borrow and drainage are exactly the variables that 2 later generations of stability work would spend their time trying to resolve. Basket-loaded fills, broadcast fills, sod blocks, and prepared surfaces document multiple construction techniques. Selected wetland-derived soils and plant inclusions indicate deliberate material sourcing. People were choosing where to dig, not simply digging where it was convenient. Radiocarbon synthesis places main construction around AD 1050 to 1150, with capping toward 1200. Construction and repair were extended public works processes requiring coordination, scheduling, technical knowledge, and large-scale labor. But here the grading has to tighten. The files do not identify the governing institution. Claims that a central authority could command thousands of laborers remain inference, not observed fact. The evidence supports large-scale coordination without fixing the political mechanism that produced it. Supported, not proven. This is the photograph that carries the argument. Trench 1, 1984. What you are looking at is basket-loaded fill. The individual soil loads carried and dumped by the builders, still visible as discrete units nearly 1,000 years later, and they are tilted. That tilt is the whole problem in a single frame. Basket loads were not laid down at an angle. If they are inclined now, either the ground beneath them has rotated or the fill has moved. This is what a slump looks like from the inside. It is also why archaeologists and engineers were forced into the same trench. The evidence for construction and the evidence for failure are the same soil. Part 2. 2 Generations of Stability Research, 1984 and 2005. Plate A. The 1984 report reproduced a 1966 base map at 1 meter contours, roughly 3¼ feet, sufficient to describe whole mound form. In this enhanced rendering, the original black line work remains authoritative. The color is an analytical overlay. It adds no contour lines, no survey control, no coordinates, and no new field observations. That rule is stated on the plate because it needs to be. A hensement that greatly amends the imagery is misclarification. It is fabrication. What the overlay is meant to make legible is the east side lobe corridor, the protruding masses on the eastern flank that prompted the investigation in the first place. Plate C. The local 1984 plan drops to a 0.30 meter contour interval, just under a foot, and the difference is decisive. At that resolution, subtle slope breaks appear that the whole mound map cannot resolve. Now look at where the work went. The trenches cluster across the lobe. They do not sample the mound randomly. That geometry is a deliberate test. Was the protruding form original construction, displaced mound fill, or some combination of the two? Later summaries describe 6 backhoe trenches and 5 solid soil borings, 3 of them extending from the 4th terrace to the mound base. Surface to core. Visible form tested against internal fill. The 1984 report is commonly summarized as reaching 3 broad conclusions. First, that slumping occurred in both ancient and modern times. Second, that the mound overlies artifact-rich pre-mound deposits whose precise character was unresolved. Third, that the mound's construction and later history are too complex to be explained by any single feature. I have to flag a records problem here, and it is not small. Bibliographic references describe that report as roughly 50 pages. The Freedom of Information release contains a cover and 2 figure pages. What is in circulation is a fragment. The Illinois State Archaeological Survey's Cahokia Finding Aids list a copy in box I-7378 in the folder for published papers by other individuals. Until that copy is produced, every summary of 1984, including this one, is a summary of a summary. 2005. Heavy precipitation through the late winter and spring reactivated the north slump on the east-facing slope and a mass wasting complex on the west. Edwin Hadjick's preliminary report was written to add stratigraphic and sedimentological observation to an engineering study and to use the same cores for geoarchaeological reconstruction. 4 continuous cores were placed where the geotechnical work was already targeting the slumps. MMD4 on the east reactivated slump, MMD1 on the west upper block near the active scarp, MMD2 in the west central drainage way, MMD3 on the west lower block. 3 of the 4 reached the mound base and the underlying alluvium. MMD1 did not. The result was both failure evidence and rare deep construction data from the same holes. Height B. The 2005 West Flank Map, enhanced under the same rule. Original linework authoritative, color analytical only. The report drew a distinction that governs everything downstream. The east and west sides of Monk's Mound are not the same problem. On the east, a main headwall scarp, minor scarps, and a toe with transverse ridges read as a single rotational slump reactivated by the wet period, though with some earth flow character at the toe. On the west, an active scarp extending longitudinally across several lobes with reversed slopes, weathered scarps, transverse ridges, and old cracks. Hadjick concluded that nearly the entire west side probably records multiple generations of slumping, rather than deliberate prehistoric terracing alone. This is the source figure behind that plate. Partial geomorphic mapping of mass movement features on the west side. Read the legend carefully, because the legend is the finding. Active slump features are distinguished from relict slump features. Main scarps are distinguished from minor scarps. Borings and monitor wells are located. The map is not a picture of a hillside. It is a chronological argument drawn in plan view. It says that what you see on the west flank of Monk's Mound is a palimpsest, a landform written over several times, and it carries a preservation consequence that is easy to miss. A repair geometry designed for a single east side rotational block cannot be assumed to describe the west. The core logs, 4 columns, described continuously with texture, dark sediment, inclusions, organic materials and stains, carbonized log fragments, and pottery sherds recorded against elevation in meters. One entry on this sheet deserves its own sentence. Shear planes and shear zone, marked in the MMD3 column. That annotation is a failure surface identified inside a stratigraphic log. It is the exact point where the geotechnical record and the archaeological record become the same document. And keep your eye on the explanation panel at upper left. Among the inclusion symbols, alongside organic stains, carbonized log, chert flake, pottery sherd, and limestone, there is a symbol for Vivianite. That is not incidental. It means the describing geoarchaeologist had the mineral in his working vocabulary before he ever opened a core. Plate D. The calibrated comparison. In every one of the 4 cores there is a black clay interval within the mound fill. Slicken sides and shear zones occur repeatedly in the upper part of that interval or at nearby contacts. On the east, in MMD4, The black clay is 31 centimeters thick, between 6.03 and 6.34 meters, with multiple shear planes in its upper part. On the west, the black clay ranges from 4 to 4 centimeters to over 4 meters in thickness, and the shear zone reaches 76 centimeters. 3 of 4 horizontal drains were not effectively draining the west slope. Now the qualification, which is the most important line on the plate. Tajik did not claim that one continuous clay sheet had been proven. The same looking black clay may represent more than one bed, and past slumping may have displaced or duplicated contacts. Unresolved. Plate D, a working failure mechanism, a model, and labeled as one. Water enters through cracks and discontinuities rather than percolating uniformly. It concentrates at or above a weak clay horizon. Strength drops. A block rotates. The rotation opens new cracks, which redirect water again. The mechanism is not simply wet soil. It is water eroded by earlier failures. That is why moisture maxima in the course do not all fall at the same contact. The model is coherent, and it is consistent with the observations. It is not, on this record, demonstrated. It is a hypothesis with a defined test. Additional strategically placed cores, dated shear zone samples, piezometers, drain records, and light are differencing. One more result from the cores, and it is a construction finding rather than a failure finding. The 6 cores from 1984 and 2005 record about 2.16 meters of relief on the buried alluvial surface beneath the mound. Haddock interpreted the higher 1984 values as evidence that Monk's Mound was placed on a local topographic high, probably enhanced by stripping roughly a meter of surrounding material in places. Core 3 was the only 2005 location where the original alluvial surface soil was preserved. Read that carefully. On this reading, the builders did not merely choose a high spot. They made one by taking the ground down around it, and in 4 of 6 cores the surface that would have recorded that decision is gone. Part 3. What the ground held. The stabilization contexts yielded cord-marked pottery, catfish spine, fish remains, bone, microdeposage, maize, nutshell, wild grape, and Eastern agricultural complex seeds. These matter archaeologically because they are provenanced, located within features or construction deposits, not because they are individually spectacular. They show cultural content. They do not, by themselves, prove elite craft production or long-distance exchange. And here the plate does something worth imitating. It separates 3 registers, direct finds from the 2007 contexts. Broader Cahokia context drawn from a historical brochure, shell beads, copper staffs, mica, projectile points, and River Elad, the 18th century mission-era assemblage, which securely demonstrates French and indigenous interaction through trade goods. Those are 3 different evidentiary things. Claims about Rocky Mountain obsidian, Appalachian mica, Gulf Coast shell, or Lake Superior copper require independent provenance evidence, and post-contact River Elad material must not be used as a proxy for pre-contact exchange. Flotation and feature samples yielded maize, possible kernels, cupules, and a gloom. Hickory nutshell, wild grape, annual weeds, wetland taxa, and Eastern agricultural complex seeds are present. Fish remains occur in features. River Elad feature 153 adds deer, raccoon, duck, gar, terrapin, turtle, mussel, and black bear. The assemblage indicates farming, foraging, fishing, and wetland resource use. Then one detail that will matter again before this film ends. Wetland indicators, quillwort, and spike-rush support borrow from moist lowland settings. The construction landscape and the subsistence landscape were the same landscape. What the corpus does not demonstrate is centralized storage, communal granaries, or administratively managed surplus. Landscape use is well supported. Redistributive economy remains unproven here. Monk's Mound's central position and exceptional scale support a planned monumental core. The broader setting includes plazas, mound clusters, boundary features, woodhenge, and domestic zones. Named satellite towns support a regional settlement hierarchy. Mound 72 provides the clearest evidence for unequal burial treatment, elaborate regalia, and special treatment, marking real social differentiation. But note how the plate labels it. Nearby regional evidence. Mound 72 is not Monk's Mound. Regional evidence is compatible with hierarchy. Specific titles and offices remain interpretive. The record supports complexity and differentiation without fixing one uniform political model. Part 4. The 2007 cuts and a preservation problem. The total removal envelope for the stabilization work is roughly 2,000 to 2,700 cubic meters, with a best estimate near 2,400 cubic meters. Systematic screening was absent by plan design. Monitoring, mapping, photography, flotation, and selective sampling were substantial. The excavation was larger than anticipated. It produced major scientific information, and it simultaneously increased the volume of soil subjected to a selective recovery protocol. The diagram on this plate states the principle in the plainest available terms. Remove in 3 dimensions and you recover relationships. Mix in bulk and you lose associations forever. Monumental architecture is evident in its own right. Once stratified soils and small artifacts intermix spoil, their original associations cannot be reconstructed. Not by better analysis, not by anything. On the released record, the review chain is genuine and a principle of minimum disturbance is stated. That should be said plainly, because it is true. What is also true is that corrected drawings, field change cure, as-built documentation, and long-term monitoring remain incomplete or unauthenticated in what has been released, and the record contains a tension that has not been reconciled. A finding of no adverse effect was made in July of 2007 under the Illinois Administrative Code at 4180.300, subsection B. A clearance letter dated the 26th of January, 2010 was issued under 4180.250, subsection B, a provision addressed to the absence of historic resources. Those two instruments are not obviously compatible with one another applied to the same monument, 3 years apart. I state that as a documented tension in the released record. I do not state it as a finding of misconduct. That distinction is the whole discipline. Part 5. A hypothesis, clearly labeled. This plate is a conjectural architectural reconstruction. It is not evidence. It is included here and shown at length, precisely because the discipline of labeling it is the point. The model proposes a buried stepped stone pyramid within the mound, 2 square outer chambers set into the west and east flanks, each capped by burned black clay, and an exterior of painted earthen surfaces in red, white, ochre, and dark earth pigments. Now the honest accounting, which the plate itself provides. No stone pyramid is reported at Monk's Mound. No square side chambers are reported at Monk's Mound. Geometry, materials, and internal layout are inferred from architectural analogy and limited data. What the model is built from is real enough. Square and rectangular structures are documented at Cahokia. Burned clay surfaces occur as floor or cap layers in some mound contexts. The mound demonstrably contains extensive fill layers, earlier surfaces, and burned architectural elements. But an assembly of true components is not a true assembly. The model is constrained so that it leaves no voids and no diagnostic artifacts beyond what is already reported, which is to say it is built to be consistent with the record rather than demonstrated by it. Contradicted, though proven, not remotely. This sits at unresolved, and it should be cited only as what it says it is. A hypothesis. Part 6. Vivianite. Blue is a clue, not a conclusion. Vivianite is a hydrated iron phosphate, iron 3 phosphate 2 with 8 waters. It is monoclinic, soft, about 1.5 to 2 on the Mohs scale, with perfect cleavage and a specific gravity near 2.7. It forms where 4 things coincide: phosphate, ferrous iron, water, and strongly reducing conditions, usually with low sulfide, so that the iron is not captured into sulfide minerals instead. Published occurrences come from lakes, rivers, canals, peat bogs, swamps, river fans, and cold seeps. It replaces organic matter in fossil bone, lake sediments, bog iron, and peat. And it changes color. Fresh material can be colorless or nearly white. On exposure, it moves through blue and bluish-green toward purple, brown, and near black. That transformation is the single most dangerous fact about this mineral for archaeology. The appearance of a residue at the moment of excavation may not match its appearance hours, days, or decades later in a museum drawer. This is the North American picture, and it is deliberately uneven. The Pacific Northwest and Western Alaska cluster carries the strongest evidence for culturally intentional use. The Mid-Atlantic cluster carries geological availability plus experimental and ethno-historic argument. Uyghur Burial. Florida's peat burial zone is included as a high-potential taphonomic environment, and for no other reason. It is not a zone of secure published indigenous Vivianite identifications. Marking a zone as promising and marking it as demonstrated are different acts, and this figure keeps them apart. Vivianite mine, and a caveat that has to be stated before anyone reads it as history. This is a sequence of documented recognition and study. Of publication, it is not a sequence of first indigenous use, which is almost certainly far older than any of these dates. Confusing a publication record with a human record is one of the most common failures in this field, and one of the easiest to avoid. Where is the evidence strongest? Melanie Ancetta's survey identifies Vivianite by X-ray fluorescence and by scanning electron microscopy with energy dispersive analysis on a set of named objects. 2 bentwood chests at the University of British Columbia Museum of Anthropology, a Teelingate shaman's oyster catcher rattle at the American Museum of Natural History, a Haida frontlet at the Burke Museum, a shaman's mask at the Fenimore Art Museum, a portrait mask at the University of Oregon. The distribution is the argument. Vivianite is rarely seen on objects of common use. It concentrates on shamans' regalia, warriors' gear, ceremonial objects, and status implements. In a survey of 300 masks, blue and tertiary fields was far more prevalent on masks attributed to shamans. 2 independent lines converge. Teelingate oral tradition, recorded by John Swanton in 1909, tells of the finding of the blue paint near Mount Edgecombe. 4 brothers discovering a cliff from which a soft blue substance continually drops, recognizing it as valuable for painting carvings, and carrying some home despite the danger attached to taking it. And in western Alaska, a Yupik exhibit names the material Kesserak, records a cliff source on Nelson Island, and preserves Elber Paul John's account of how difficult that deposit was to reach. That is not merely a mineral occurrence record, that is a blue mineral source held inside a living technical vocabulary. Now the counter-discipline. Vivianite can be cultural, or it can be taphonomic. Guidance from the Society for Historical Archaeology notes that bone and iron together can form a blue iron phosphorus compound, and warns that such stains are generally harmless and should not be removed without conservator input. A Smithsonian forensic case makes the point in the most vivid possible way. Whitish blue material on teeth and jawbones turn dark blue on exposure to air associated with nearby iron objects. That case was not Native American archaeology, but the chemistry does not care about the archaeology. Wherever bone, phosphate, iron, water, and reducing conditions overlap, the same mineral can grow. So a blue residue on human remains is not automatically intentional paint. On a Northwest Coast mask, blue may well be deliberate Vivianite with ceremonial significance. On a tooth from a peat burial, blue may be post-burial iron phosphate. Only context plus multi-method analysis distinguishes those cases. And here I have to correct myself, on the record, because that is how this works. An earlier reading of this corpus concluded that no Vivianite was reported at Monk's Mound. That conclusion was wrong. It was drawn from the searchable documents, and the 2005 stratigraphic evaluation is a scanned document. It is not searchable. It had to be optically recognized before it would answer the question. When it was answered immediately, Vivianite appears twice. It appears in the explanation panel of the correlate figure as a mapped inclusion category, and it appears in Appendix A inside the continuous core description for MMD 1, the west upper block core near the active scarp, the one core that did not reach the mound base. The interval is 14.03 to 14.36 meters. Sample 15C49. The unit is black clay, 2.5 YN0 and 2.5 Y2.5/1. With silt loam inclusions and uncarbonized organic material. And then the phrase, in Hadjick's own descriptive shorthand, few beds with few fine Vivianite. A description mark as above repeats the same unit at 14.88 to 14.95 meters. That interval alignment is read from the sequence of descriptions against the interval column, with 2 no recovery gaps confirming the registration. It should be checked against the original page before it is cited. The presence of the word should not. So what does the entry prove? It proves that Vivianite was recorded by a working geoarchaeologist inside Monk's Mound at depth. That is now a documented fact rather than a hypothesis, and this film was wrong to place it any lower. It also sits in exactly the setting the mineralogy predicts. Black clay, wetland-derived borrow soils, uncarbonized organic material, and wood preserved at depth. Persistent wet zones that 3 of 4 horizontal drains failed to drain. Phosphate, iron, water. Low oxygen, decaying organics, all in the same column of soil. Now what it does not prove, and this is where the discipline earns its key. The identification is a field identification made by a during core description. There is no Raman, no infrared, No X-ray diffraction in the released record. The phase is not analytically confirmed, and Vivianite has alteration products that a hand lens will not separate from it. And the origin is untested. In a wet-reducing deposit, diagenetic growth is the default reading. Nothing in that entry claims pigment, and neither do I. What has changed is not the answer. What has changed is that the question now has a location, a depth, a sample number, and a core. So, what would testing look like? The protocol is layered, never single test. First, high-resolution photography and in situ description before exposure-driven color change proceeds. Second, microscopic assessment of color distribution, substrate, and stratigraphy. Third, first-pass elemental screening, portable X-ray fluorescence or scanning electron microscopy with energy dispersive spectroscopy to establish whether iron and phosphorus are paired and whether copper, cobalt, or sodium-sulfur signatures of alternative blues dominate instead. Fourth, phase confirmation by micro-Raman or infrared spectroscopy and ideally micro-X-ray diffraction, which remains the most defensible way to separate Vivianite from alteration products such as meta-Vivianite. And two sampling rules. Where Vivianite incrustation is present, DNA samples should be taken away from the incrustation, and nothing should be consolidated, wet cleaned, or stain removed without a conservator, least of all on human remains. In indigenous heritage work, all of it belongs inside consultation with descendant communities, because oral tradition and object function materially change what blue means. What remains open, whether the black clay is one continuous bed or several similar beds, which controls whether a single failure surface can be projected between cores, whether older failures moved along the same horizon, how past slumps rerouted water, what the original west flank form was before slumping reshaped it, whether the additional borings and lidar that Hajic said were needed were ever completed, where the complete follow-up report is, the one the preliminary report promised, with dating and geochemical analyses, and where the complete 1984 monograph is, beyond a 3-page fragment and a box number. To that list this film adds 3, which are new. Whether sample 15C49 was retained, and where it is curated now. Whether the MMD1 Vivianite has ever been analytically confirmed by Raman, infrared, or X-ray diffraction. And whether the other 3 cores carry the same inclusion symbol on their logs, unremarked in the running text. None of these are rhetorical questions. Each has a named next record, or a named next test. The last 3 have a sample number. Mound is both an engineered soil mass and a stratified archaeological record. Every dispute in this film descends from that single fact. The preservation lesson is methodological as much as archaeological. Preserve three-dimensional provenience. Preserve soil interfaces. Preserve sample context. Preserve the authorizing decision chain. What was not recorded cannot be recovered. What was recorded, but not released, can be. Barrow's Research. Capital Development Board Project 104. 021-016. Illinois Historic Preservation Agency Log 022062207. Compiled from the Freedom of Information Release, the 1984 McGimsey and Wyant Fragment, the 2005 Hajic Preliminary Evaluation, and a Vivianite Literature Review current to July 2026.